This is an example with regards to confidence intervals and determining the margin of error for a confidence interval. And I want to talk you through how we go about doing that. So the example says, use the data on the number of friends for 30 users in the social networking site and determine a 95% confidence interval to find the margin of error for the mean number of friends for all users of this social networking website. Now, in a confidence interval for a mean, we know to use the following formula. Take the sample average, x bar, and then determine the margin of error. So what follows the margin of the plus or minus, is the margin of error. That margin of error is calculated based upon the number of standard deviations out from that sample average that we need to go to capture the middle 95% in this case. That critical value, as it's referred to, is then multiplied by what's called the standard error. The standard error is determined by taking the standard deviation and dividing by the square root of our sample size. So here we have a set of 30 individuals that use this social networking website, and we want to determine the margin of error. So the first thing we have to recognize is that if we go to our table of critical values for the normal curve, we see that for 95% confidence, we have to go about 1.96 standard deviations out in both directions of the center, both below and above, to capture the middle 95%. Let me demonstrate that with a picture. So if we're looking at what's called the standard normal curve, we have to go out almost 2 standard deviations below to almost 2 standard deviations above to capture that middle 95% of a normal curve. So that's where the 1.96 comes from. Now the next question is, how do we determine this standard deviation? And this ties in with something we've learned previously in this course. Standard deviation measures average spread away from the mean. Well, we've learned that there is a formula that can be used to determine that average spread away from the mean. And that formula is as follows. Take each value of x, all 30 of them, one at a time, and figure out how different they are from the mean by subtracting that value of x minus the mean. Then square that difference, add those all up, and then finally divide by 1 fewer than the number of pieces of data that we have in our data set. That gives us what's called the variance. The standard deviation then is the square root of that. And again, it will give us the average spread away from the mean. So here in my little table that I created in Excel, I listed first in the far left column all the values of x that we saw displayed in that table on the previous slide. 162, 249, and so on. That's the number of friends that each of the 30 individuals in our sample had on this particular social networking website. In the second column that I've labeled x minus the mean, I took the mean, which I determined by adding up all those values of x and dividing by 30, and that mean I got to be equal to 138.5. And I took each value of x and I subtracted that mean. So my first value of x was 162. I subtracted 138.5, and I got 23.5. My next value of x was 249. I subtracted that mean again of 138.5, and I got a difference of 110.5. And I continued to do that for all 30 individuals in my sample, the last of which had 124 friends, I subtracted the mean of 138.5, and I got a difference of negative 14.5. So what I've calculated there is each of these x minus the means. The formula then says I have to square them. So in my next column, you notice I've labeled it x minus the mean squared. So for each value of x minus the mean, the first being 23.5, I had to square that to determine that difference squared, and I got 552.25. I did that then for the next difference between x and the mean of 110.5. I squared it, and I got 12,210.25. And I continued to do that for all 30 deviations from the mean. That gave me each of these values, the x minus mean quantity squared. Then my formula tells me that I have to add up all those squared deviations. So when I add up all those numbers in the column on the right, I got a sum of 75,565.1. Or 0.5, excuse me. That's the numerator portion of this variance. I then had to divide by one fewer than the number of pieces of data that I have. N minus 1 would be 29. And when I calculate that value, I have what's called the variance. In this case, my variance comes out equal to 2,605.706,897, and so on, running out of space. To determine my standard deviation, I have to take the square root of that value. And I get a standard deviation. If I round, say, to the nearest tenth, I get a standard deviation equal to 51.05. So now back to calculating my margin of error. We determined that the critical value was 1.96. We now know that our standard deviation is 51.05, or if I round to the nearest tenth, that's 51.0. And we divide that by the square root of n, which in this case would be square root of 30. And when we do that, we get a margin of error of 18.3 if I again round to the nearest tenth. So, in reference to this example, we have determined that to construct a 95% confidence interval, to estimate the true average number of friends that all people using this website have, I have to take my sample average, which was 138.5 friends, and add and subtract about 18.3 friends to capture the middle 95% of that distribution. So my margin of error is 18.3.